So what we were talking about yesterday was, or Monday, was we were trying to sketch these graphs to the best of our ability by looking at the slopes of the function. We're trying to graph the first. Alright, so what we need to do here is we need to establish some formal guidelines. Alright, we have to get, on Monday we were sort of just looking at the slopes and we say, oh, okay, well the slope of this line is positive, so that means that when we graph our derivative, those y values would be positive, so they'd be above the x-axis. Alright, so what we have here is we actually have some actual rules here and some statements. So when f of x is increasing, alright, so when the function, the original function is increasing, it tells us something about its first derivative. It tells us that the first derivative, so f prime of x, is positive. Alright. We were kind of getting at that on Monday, we just weren't formally the same. So if you look at your original function, your function f of x, and it's increasing on some interval, you know that from that interval to that interval, that derivative is going to have positive y values. Okay? So it also goes backwards. If you know that the first derivative is positive, you know that the original function is increasing. Okay? So we come down to when f of x is decreasing. When f of x is decreasing, the first derivative is going to be negative. So the first derivative is negative. Okay? So what that allows us to say is, if we're looking at our original function, and we notice that function is decreasing from a to b, then we know that the first derivative from a to b, and all the points in between, is also going to be negative. All right. Now, this next part is probably sort of like granddaddy of them all. It says when f of x has smooth, all right. So when f of x is smooth, this is essentially meaning it is constant, kind of. When f of x has essentially a maximum, a minimum, or a shelf. A shelf would be something where you go like x cubed. X looks like this right here. That. So you have that type of thing. I'm sure you'll probably know that in the food. Alright, that would be a shelf. Now, if you notice, if you look at this, the reason it's called a shelf is because it's sort of like you just set something there. Alright? This function would be, this function right here is increasing, increasing, increasing. It's still increasing right there. Alright? It goes increasing, 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 little shelf, and then it starts increasing again. It never starts decreasing. So we have to know here, so when f of x has a maximum, minimum, or what we're going to call a shelf, then that tells us that f prime of x, the first derivative is equal to 0. Alright. So again, if we know the first derivative is 0, we know that there is either a maximum, minimum, or a shelf. And eventually, what we're going to know how to do is we're going to say, okay, we know where that first derivative is 0. We're going to do this today. What is it? What does it have there? Is it a minimum, maximum, a shelf? We have to figure that out. Alright. And then finally, you have when f of x has a cusp, corner, vertical tangent, or discontinuity. Your first derivative, f prime of x, does not exist. It is not differentiable. Alright? So, we talked about that already. Now, our goal here is we're going to take these 4 pieces of information that we have, 4 sort of guidelines. And we are going to use these to either do one of two things. We're either going to see the graph of f of x, or we're going to see, so we're either going to see the graph of f of x, and then we want to draw the graph of the derivative, or we're going to see the graph of the derivative, and we want to draw the graph of the function. Okay? So, this is our first graph. You guys have this and data in, all right? So, what we're going to do here, nope, right there. All right, bring that out. Yes. Yes. All right, so we want to figure out, this is the, it says, given the graph of x, so this is the original function, sketch the derivative f prime of x. All right, so first things first, what we need to do is the best thing to do is you go through and sort of label where f of x is decreasing, where it's increasing, where it's a maximum, where it's a minimum, and where it might be the shelves, here is the shelf. All right, so first of all, at what points are there minimums or maximums on this graph? Sure. Here? Yes. So this is the minimum. That's actually negative 4. Negative. So here's the minimum right here at x equals negative 4. Here's the minimum here at x equals 4. Here's the minimum or maximum here at x equals 0. Alright? So we have a minimum. We have a minimum. And we have a maximum. Now, what is the first derivative equal to when we have a minimum or a maximum? Copy page. 0. So, f prime of x is equal to 0. And I'm going to cheat, and I'm going to copy that. And f prime of x is equal to 0. And f prime of x is equal to 0. Alright. So, what we can do now is we can come over here and we can plot those on our graph. So we have, looks like it's down to 4, maybe 2.
Shamar has the vote.
You guys voted for it.
Me? I need to go to the circle. And Michelle owns me, not Michelle Shamar. Because she's running that, she did.
So, and we have negative 4, and we have 8, or negative 8. Alright, so, smaller. Alright, so, we know that the first derivative is going to be equal to 0 at negative 4, so I plot that right there. At 0 and at 4. Alright, so again, this is my f prime of x-axis, this is my x-axis. So, what we look at now is we need to figure out where is this function increasing or decreasing. Right? So, we look over here, this function going up, it's just keep going up over there. But from negative 8 to negative 4 is this function increasing or decreasing? It's decreasing. So this function decreases. What does that tell us about the first derivative over here?
Negative.
So it's going to be negative. So f prime of x is less than 0. Alright, that's the way right. Where else would the first derivative would it be equal to 0?
Right. Okay, 0 and 4.
Okay, 0 and 4. So f prime of x is equal to less than 0. All right. Any other places? No. All right. So what about from, or so where is it? Where is this function increasing? Where's fx increasing? Negative 40. It says 4 and you guys get it, but yeah, negative 40. So f prime of x is greater than 0 here. Anywhere else is increasing? 4 to, well, 4 to what? There's what? So f prime of x is greater than 0 there. Alright, so now all we need to do is sketch our graph. Okay? So we know that from negative infinity to negative 4, this function is decreasing, which means that our first derivative is negative, which means that the y values of our first derivative are negative. Alright? So all the way down there. Then we know from negative 4 to 0, this function is increasing. That tells us that our function is, our first derivative is positive. Alright? So we're going to go. So we know it's going to have positive y values up to there, come back down. Then we know from 0 to 4, this function is decreasing, so the first derivative is negative. So that tells us that we need to go down and then back up to 4. So we go down here, go back up. And then from 4 to infinity, this function is increasing, so then it is positive. All the first derivative values are positive after we get to x. Alright. So right there, we have now sketched a example or a picture of the first derivative. That's it. So the idea is that you want to be able to identify where the function is increasing or decreasing, or where the shelf or maximum or minimum, and then use that information to graph the function. Alright. So I would personally always start with by asking myself, where is the maximum, minimum, or shelf? Okay. So right here. So it says, given the graph of f, sketch the derivative of f. Alright? So what's the first thing that we should sort of automatically recognize here? The inverted asymptote. Good. It's that, well, we're going to say that x equals 0. Alright? So if there's a vertical asymptote, that means that the function is not continuous, which means that this function is not differentiable. So what does that tell us about the first derivative graph? It doesn't exist at x equals 0. So that tells us that since this graph has like a vertical asymptote, our first derivative should have a vertical asymptote at x equals 0 as well. Alright? So if we look at this, okay, are there any maximums or minimums? Yeah, well, technically, I guess you could say that, but no, because infinity you can't actually, negative infinity you can't actually do. So there's no actual maximum or minimum. So we've done that. There's nowhere on this graph where the derivative equals 0. All right. Now, next thing we do, looking from left to right, does this function decrease anywhere? So here. So it starts decreasing. So where is it decreasing? Yeah. So let me just point this out. This looks like it's not increasing or decreasing here. But if we're to take this and graph it on a graph calculator and see many where it goes, this would be decreasing. Negative infinity to what? 0. This function is decreasing, which tells us that our first derivative is what? Less than 0 or negative. Right? What about on the other side of the graph? Is this function increasing or decreasing? Increasing. Alright, so we say f prime of x is greater than 0. Are we taking care of everything? Have we looked at the entire graph? Yes. Alright, so it tells us that on the left hand side, f prime of x is less than 0. Okay, what you'll notice is it starts out sort of pretty flat here, right? And then the closer we get to 0, the closer the steeper the slope gets, right? So the bigger, kind of the more negative the first derivative value is. So this might be like negative 1 right here. This might be negative like 4 right here. This might be like negative 100 right here. All right. So what we're doing is, again, since it's decreasing, all right, we know that the slope or the first derivative is less than 0, which is negative. So our function, first derivative on that side is actually going to look just like the same. All right. Now over here, it says that our function is, we said our function is increasing, which tells us the first derivative is greater than 0, which, if you look at this slope is very, 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 very steep. It's a very, very big number when it's really close to 0, right? So that means when I'm really close to 0, my first derivative value is going to be very, very high. And then as we get further away from 0, the slope gets closer to 0. So that tells me that it's going to look like this. Right. And then notice again, it is not differentiable at x equals 0. Therefore, we don't have this, we don't have the first derivative never cross the y-axis. Also, it never crosses the x-axis because the function doesn't have any maximums, minimums, or shelves. So pretty making sense, straightforward stuff? Yeah? So now, this one's a little bit different now. Alright? The first two graphs we looked at, we were looking at the graph of the original function, x. This says, given the graph of the derivative f prime, so we're given the graph of the first derivative, sketch a possible graph of f.
Alright. So, let me just get straight line on this. No, the graph of x is, what is it?
That's the graph, that's 2.
So, the graph of x is, okay?
No. Think about it. So, what is the graph of f prime tell us? Or what is the first derivative tell us? What is the first derivative tell us about the original function? What does it tell us about a function at a certain point? If we find the first derivative, we plug the value in, what is that value? Is that number? So, alright. So the graph of the first derivative is a graph of the slope of the original function. So, what is the equation of that line? Y equals what? Y equals what number is that? 2. Right? So, what this tells us, and again, this is the graph of f prime right here. Alright? The graph of f prime of x. So, what this is telling us is that, let's just put an x argument there. At x equals -1, the slope of f is 2. X equals -2, the slope of f is 2. X equals 1, the slope of f is 2. At x equals 2, the slope of f is 2. At x equals 1,000, the slope of f is 2. So this function, the original function, has a slope of 2 everywhere. x squared, the slope changes depending on what point you're at. All right. So, what type of function has a constant slope? What? A linear function. So, if this has a slope of 2, we need to write a linear function that. We need to graph a linear function that has a slope of 2. So, what's the most basic linear function that we know that has a slope of 2? What is it? 2x. So, f of x. So, this is our first derivative. So, our first derivative would be f prime of 2. Our original function would have been, could have been 2x. It could have been something else. Yeah, we're trying to graph the original function. So, what we need to draw is a function that has a slope of 2. So we can just sort of set this up. So there's a graph. There's a graph of a possible function, right? Notice it says sketch a possible graph. All right. We sketched a graph of f of x equals 2x. But let me ask you this question. This is like getting way ahead of ourselves, because we're going to talk a lot about this more like in January and February. So do we agree this function right here that Shamar said f of x equals 2x, this has a slope of 2 every x value, right? But couldn't I graph this function too, and that would still have a slope of f of x, or of 2, right? The first derivative, that would still be the graph of this. That first derivative would still be the graph of this function's first derivative. All right. This could, if I can move it up, this could still be the graph of f of x. So there's a possible graph of x. So when you're given the first derivative, which you might want to write this down, when you're given the first derivative, there is more than one possible f of x that you can graph. So when you're given f prime of x, there could be more than one f of x. So more than one f of x. That's gonna play a big role in what we talk about later in the class when we start talking about what we call integration. Okay. So questions so far? And I know initially I heard she said now it makes sense. You said wouldn't it just be a straight line along the x axis? I think you're still at the point thinking that is when you're still thinking this is f of x. You have to make sure you read the question correctly. Because on the AP test, they're going to do that. They're going to ask, when they'll ask these types of questions, and it'll be like, what is, and if you don't read it correctly, you might be looking at the wrong graph. You might be thinking F5 is that. Okay? Because, we're on this part right here. Alright, so, before we start going, Michelle, what are we given and what are we trying to graph? Yep. Good. Now you have to find the original function or a possible original function. There's more than one right answer. Alright, so, good. So let's look at this. We have a first one. Now this one was a little bit, let's backtrack real quick. This is positive 2 everywhere, right? So kind of sort of put that off to the side. We saw, okay, we know that the same slope is due, but this is positive 2 the entire time. So what does that tell us about our original function? Is it going to be increasing or decreasing? Increasing, because since the first derivative is positive at all x values, that means this function is going to be increasing at all x values. So you can go back and think about that. Shamari, the first thing you said was, is it x squared? Well, x squared, is that, if you think about that, is x squared, is that graph increasing the entire time? No, it's going to do that. So there's one reason why it's not. So, let's look at this. So from, let's say from negative infinity to 0, all right, what is happening? The first derivative is what? What value is the first derivative? What type of value? First derivative has negative y values here. As positive. So right here, f prime of x is greater than 0, positive. That tells us that f of x is increasing. Okay. Now, right here, f prime of x is equal to what? So that tells us what? If the derivative is equal to 0, that tells us, if you go back on that front page, if the first derivative is equal to 0, so that tells us that there is either a maximum, minimum, or shelf. Alright? So we have to figure out which one that's going to be. But we know that's happening at x equals 0. Okay? Now, look over here. From 0 to negative infinity, what types of values is the first derivative have? As negative. So it says, so we know the first derivative is less than 0 here. So that tells us that f of x is doing what? Decreasing. Alright? So let's try to sketch it. Now, first off, the first thing you want to kind of figure out is this going to be a maximum, minimum, or a shelf? So let's think about this. If our function is going, so we're saying f of x is increasing. So if f of x increases and then it starts decreasing, what type of value is that going to give us? A maximum, minimum, or shelf? You can start going. It's increasing, right? It needs to start decreasing, right? So x equals 0 needs to start decreasing. So I just want to go that. So we know from negative infinity to 0, this function is increasing. Alright. We know that there from 0 to negative or 0 to infinity is decreasing. What's the only possible thing that can go there? A what? A maximum, minimum, or shelf? Maximum. Alright? So we know that right here, there has to be a maximum. Okay? Now, that leads us to be able to include something. Okay? So what we can say here is, if we look at the derivative or the original function, so we look at the first derivative, right? So if the first derivative, f prime of x, is greater than 0, okay? And then f prime of x is less than 0, okay? That tells us that f of x has what? A maximum. Because that's what we just said here. Again, going from f prime is greater than 0 to f prime being negative, we have a maximum. Alright? So that gives us a maximum at x equals a. Okay. If f prime of x goes from being negative and then opposed to being positive, that tells us that it's going to have what? A minimum. Right? And then we have two cases. If f prime of x goes to being positive, and then positive again, alright? Or if it goes from f prime of x being negative, and then f prime of x being negative, that's going to give us a shelf. Right? So if the derivative doesn't change value, it gives us a shelf. So typically what would happen is the derivative will go from being positive 0 to positive, or negative 0 to negative. That makes sense there? I'm saying that?
I would.
Alright. So you guys get it. So the big part of calculus is not going to be you guys sketching graphs. The big part of calculus is you guys are going to be given a function, and you have to use the function, use like algebra to figure out where the function is. Alright? Even when you can't look at a graph. So look at this. Alright? It says, given the graph of f prime of x, sketch a possible graph of f. So this is the first derivative. We want to sketch f of x. Alright? So what would be the first, what would be the first thing we want to look at in this? The what? Okay, so let's think about this. This is the graph of what? First derivative of what? The graph of the first derivative. So the first derivative, you want to start looking at where is the first derivative negative, where is the first derivative positive, and where is the first derivative equal. Okay. So first of all, if we have this graph, where is the first derivative equal to 0? Is the first derivative is equal to 0 there? First derivative is equal to 0 at negative 4 and at 4. So this tells us at negative 4 and 4 that we're going to have a potential what? If you go back and look at that first page, alright, it says f prime of x is equal to 0. You need to have a maximum, minimum, or a shelf. Alright? So, also keep this available. It's right above what we just worked on. So, where are you going to have a maximum, minimum, or shelf here? The maximum, minimum, or shelf there. Right? So, let's think about this. Can you do this first? This first derivative is equal to, has what values? It's negative. Don't get confused. This is not f. This is the first derivative. So the first derivative right here, the y values are, remember this is our first derivative of x values. The y value is negative. So this from here to here is negative. That tells us that f of x is doing what? F of x is decreasing. Right? Because f prime of x is less than 0. Now, is there anywhere else where the first derivative is equal to, or is less than 0, where it's negative? So, is there anywhere else where the first derivative is negative? Or what? or two, these are here. So, right here is, you know, the first derivative is less than 0, which tells you that f of x is decreasing. Okay, good. So, the rest of the places, so the first derivative is positive between -4 and 4, right? So that's positive all throughout here. So that tells us that if the first derivative is positive, so it's greater than 0, what's that tell us about the original function? We increase it. Okay? So, let's go back over here. We need to create our, let me put these points on there. 4, 4. Alright, so, let me ask you this, are we going to have a maximum or a minimum at x equals -4? Why a minimum? Why would it be? Because b left to right, so f prime x is what? Well, not f prime x is 0. F prime x is less than 0. So f prime x is less than 0. We get to here, it's 0 now, so there's a maximum or minimum or a shelf here. And then now f prime x is positive. What if we just write down about if f prime x goes from being negative to positive, it tells us that there is what there? And there's a minimum. So I know that -4, there's going to be some form of minimum. So I'm just going to put a form up there. Alright? Alright. Now, what about at positive 4? Is there going to be a maximum or a minimum? Well, from that positive 4, it's going from f to the first derivative being positive to the first derivative being negative. So what does that tell us? What? A maximum. So we know that positive 4 can be some form of maximum. Okay? So, at this point, we might be ready to start graphing. Okay? So, we know from negative infinity to -4, this function is decreasing. Right? So it's decreasing it. Alright? From -4 to -4 to 4, this function is increasing. Correct? Right? And then from 4 to infinity, this function is doing what? Decreasing, because f prime is negative. What is the function? Notice, it says 1 turning point. No, it's 3 turning points, or 2 turning points. How many turning points do you think a function has, or a derivative that has 3 turning points? How many turning points does a function have? That should make sense. This is
Okay,
this.
so you're talking about in the beginning when you the other way around.
Yeah, see, that has 4, it has 3 turning, that, the original function has 3 turning points. Now that first derivative has 2. So, alright. So, tomorrow, we are, actually, so, let's just, first of all, what are we given here? First derivative, you're trying to graph what? Okay. Here's what I'm going to do. I'm going to give you guys, I want you all to work together to create this greater graph on the, oh, actually, no, these ones are good. This is good. Alright, you gotta do this. Alright, so, give me a graph of the derivative, that's fine. So what's the first thing we want to do? You want to see where f prime is increasing or decreasing, or do you want to see where f prime is positive or negative? Yes. So f prime has negative values when? Alright, here. When is, on this graph right here, when are the values of f prime of x negative? Right here it's 0. Okay, so what would the interval be? So negative infinity to negative 6. We know that f prime of x is less than 0, which tells us that f of x is going what? Decreasing. Alright, so at negative 6, what happens? What's the value of f prime there? That's going to be, that tells you that f prime of x is equal to 0. Now, so well, let's just try and do this before you look at it. If f of x is decreasing here, and then f prime of x is positive up here, that means that f of x is going to be doing what after negative 6? So f of x is going to start increasing. So if we go from decreasing to increasing, what does that tell us? This is going to be a 0 or a minimum? Good. So this is going to be a minimum. All right. Now, let's look at this next part. What happens from negative 6 to what? So right there, what happens to negative 6 to, say, well, actually, what happens right here, x equals 0? It's equal to 0, right? F prime of x is equal to 0. So that tells us that there's either a maximum, a minimum, or a shelf. Now, if we're looking at this, right here at x equals 0, does the first derivative change from being positive to negative to positive? Or does it go positive, 0, positive? That's the positive 1. So the value of our first derivative is positive, 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 0, positive, 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 positive. It's a shelf. So when the value of the first derivative does not change from positive to negative or negative to positive. So if it goes positive, 0, positive, or negative, 0, negative, it doesn't, it's going to be a shelf. If it goes positive, 0, negative, or negative, 0, positive, then you get a maximum point. So that's a shelf. So back to this. From negative 6 to 0, f prime of x is greater than 0. So that tells us that f of x is doing what? Increasing. And from 0 to 6, f prime of x is greater than 0. So f of x is increasing. All right. We're at 6. What's happening at x equals 6 right here? 0, right? So that tells us that. So it's going from positive, so the first one is going positive, then negative. So what does that tell us this is going to be right here? So the first one is going positive, 0, negative. So what would that tell us? Maximum or minimum? Maximum. Alright. So finally, from 6 to infinity, f of x is decreasing because f prime of x is 0, negative. Okay? So, now we have to graph that. Okay? So, we have, we'll go ahead and put our maximums and minimums and whatnot on there. So, at negative 6. At negative 6, there is a minimum. So, we're going to put it down here. At positive 6, there is a maximum. And we'll deal with x equals 0, there's going to be a shelf of some sort. Alright. From negative infinity to negative 6, this function is decreasing. Alright? From negative 6 to 0, this function is increasing. At 0, there's a shelf. Alright, so at 0 there's a shelf. Just notice something like that. And I'm exaggerating that. That's a really big exaggeration. And then it's going to increase some more from 0 to 6. Alright? And then from 6 to positive infinity, it's decreasing. There's our function. How was that? Made noise out of it.
Yeah.
Alright. Okay, so move it over there.
Oh, well, I mean, there's a line for it.
Given the graph of the derivative f prime, sketch a possible graph of f. Well, you guys help me.
Yeah.
That's fine. Just think about it.
So, listen.
Yes.
So, is the reason the first guy come over?
Yes, because that would mean that at the first derivative of x equals 0 is not differential.
What is that doing? The first page that we get? A lot?
It's on this page. Alright, so let's look at this. From negative infinity to negative 4, this function is doing what? This is the first derivative here. So, first derivative is negative, so f of x is doing what? Decreasing. Okay, that's from there to there. What are we going to have right here at negative 4? What's the value of our derivative there? 0. So f of x is decreasing here because the first derivative is negative. First derivative here is going to be positive. So that tells us that f of x is doing what? Increasing. We'll come back to that. At positive 4. Okay, so if this goes from decreasing to increasing, this is going to be what type of extreme? Maximum or minimum or shelf? What? It goes from decreasing to increasing, so it's a minimum. Okay, so over here, this first derivative is positive right there. f prime of x is greater than 0, so f of x is going to be what? Increasing or decreasing? Increasing. And then f prime of x is less than 0, so it's going to be f of x is decreasing. So if we go from increasing to decreasing, that's going to give us what type of maximum? Good. That'd be maximum. All right. So we also know that right here, that is not differential there. So that tells us that there should be what type of possible thing there. Yeah. Oh, I guess I gotta do attendance. I don't know. All right. So, alright, so what we do here is, okay, so first of all, we know this is not differential, so we either have a jump there or a hold there, so sort of depends on what you guys want. You want to jump? Alright, so we know that there's going to be a minimum at x equals negative 4. It is a possible graph. Alright? And we know there's going to be a maximum at x equals 4. Okay? So here's what we know. We know from negative infinity to negative 4 that the first derivative is less than 0, which means that f of x is decreasing. So it's decreasing to there. Okay? Then we know that from 4 to 0 is increasing. Alright, so we're going to make a jump. So we know that right there is differential. Now, if there's a jump discontinuity, alright, that means that the limits from both sides will be different. So that means that we better go ahead and put the other part of the jump down here. Okay? Now, from 0 to 4, it is increasing. And then from 4 to 0, it is decreasing. And there would be a possible function. Okay. Another possible function that you can have would be, I'll draw it in green. See if you would. That. And then maybe.
Mr. Staff, I apologize for this interruption. We have some gentlemen here from the health department that have to do their annual inspection. They do not want to cause much disruption to the instructional process, but they will be entering some classrooms. So don't be alarmed. They will be stepping in and doing what they need to do to cause as much disruption as possible. So please make them feel welcome into our building. Thank you.
I mean, I couldn't have it, you know, I couldn't just sort of have all the so if that, we had a whole, you know, going up off the graph a little bit, off the page, but that's a whole there, so it's not differential. Alright? So, there's two more to look at. So sketch f of x given the following. F of 2 equals 0. F is continuous everywhere. F prime of x is equal to negative 3 when x is less than 1, and 2 when x is larger than 1. Okay? So let's think about this here. We should probably first of all put some things on our graph. Alright. First thing I'm gonna do is put the one thing that is definitely not gonna change at all. F of 2 is equal to 0. Alright, so F of 2 equals 0, it tells me that F of 2, F equals 2, y equals 0. That makes sense? It says when x equals 2, y equals 0, so we'll go with that. It says that f is continuous everywhere, okay? And it tells us that f prime of x is differentiable, and with the derivative of f prime, so f prime of x is equal to -3 whenever x is less than 1. So that tells us a couple things. Since f prime of x is less than is equal to -3, that tells us when x is less than 1, f of x is doing what? It's up, or decreasing. Right? And when x is larger than 1, it tells us that f of x is doing what? Why is it increasing? Because the first derivative is positive. Now, thinking back, so again, this is saying at every x value less than -1, the slope is -3. And at every x value larger than 1, the slope is 2. So if we go back and look, we have that one right here. When f prime of x is equal to 2, our derivative graph of a straight line, our function graph turned out to be a linear function with a slope of 2. So this piece, when x is less than -1, is going to have a slope of -3. So your linear function with a slope of -3. And 2, x is less than, for all x larger than 1, it's going to have a slope of 2. Now, notice that it says x is less than and x is greater than. It doesn't say x is less than or x is less than equal to or greater than. That means that the first derivative does not exist at x equals 1. Right? What did I just say? Does not exist at x equals 1. Okay? So, that means that we're going to have, what, a corner or a hole or discontinuity of some sort. Okay? But, so it says what? Good. So, that's a good question. How can we have a discontinuity if it says f is continuous everywhere? You can't. So that automatically tells you it's not going to be a hole, it's not going to be a vertical asymptote, and it's not going to be a jump. So that tells us it's going to be either a corner cusp or a vertical tangent. I'm going with a corner. Alright? So, when x is less than 1, I need to put a slope of less than negative, I need to put a slope of -3 on there. Alright, so, let's go ahead and put slope of -3. Well, we're going to make a slope of -3. Well, first of all, we know that it's also, since the first derivative is negative, is decreasing. So, let's just do this.
Basically, just interruption. Option A white, please come to the attendance office. Option A white, attendance, please.
Stop the this one there. Thank you, hard. Thank you, hard. Alright. And so we're going to put a corner. And we'll make it look like. Alright, notice x is larger than 1, f of x is increasing because it's positive. X is less than 1, our function is decreasing because our first derivative is negative. This function is continuous everywhere, because it is continuous at corners, and f of 2 equals 0. Boom.
Wait, so what made us
thing that it had to be,
Where was the custom line?
Custom look like, custom look. Okay, so good question. So why wouldn't it be a custom, and why wouldn't it be a vertical tangent? Alright? Is this made up of is this cusp made up of two linear lines? No, this is not always, the slope of this function right here is not always be -3. So this function will not always be 2. It's telling us that the slope is always -3 and 2. So it can't be that. This, no. Alright? That makes sense though? Mark? So, that's what. Sure. What? Then write this down, so you wouldn't have to graph it. Base is not equal. Alright. No, Shamara will not be your homework. Alright, so I'm only gonna put, this goes up to 2, this out to 3. Alright, so let's just, first of all, I'm drawing a graph of G of X. Alright? So the first thing I'm going to do is I'm going to look at the 4 things it tells me. And it tells me, does it tell me anything about G of X that I know it has to be true? And it does. It tells me that G of 0 is equal to 0. Okay, good. So Shamar said that G of 0 is equal to 0. So that means right there, there's a function value, there's a point at 0, 0. She got it. Now, here's the next, so now we're going to look at the rest of these things. It says G prime of 0, G prime of 1, G prime of 2. It's telling us stuff. It's saying the first derivative at this point is equal to this. The first derivative at a point tells us what? It gives us the what? The slope. So it's telling me right now, and I'm just, it's also a sketch of possible graph. So there's more than one answer. It's telling me at x equals 0, the slope is equal to like x equals 3. Alright? So that's me a pretty deep, or steep slope. So I'm going to put like this. Alright? So a steep slope right there. At x equals 1, it's telling me that the slope is 0. So that's telling me that I'm gonna have a maximum or minimum slope. So that there it's going to be equal to slope of 0. Okay?
Wait, there?
At x equals 1, because g prime of 1 is equal to 0. At g prime of 2, my slope is equal to -1. So that tells me that it's going to be going, that my function is going to be going, decreasing from slope of like -1 to something like that. Alright? So I'm just going to draw a graph. Boom. You're done. Is that my graph? Does it match? Does it meet the expectation? Does G of 0 equal 0? Yes. Does G prime of 0 equal 3? Yes. I made a pretty steep slope right there. Is G prime of 1, is the first derivative of that x equals 1 equal 0? Yes. Is the first derivative of that x equals 2 equal -1? So I said it did. I made it look like that. Right here. Alright. That's about a slope of -1. That's a slope of 0. That's a slope of 3. Yeah, it's a sketch. Weird.